Hi, everybody. Welcome to my channel, Numbers with Nora. This is a math tutoring channel where you can get all your math help and needs and homework questions and answers and stuff like that. For this particular video, we're going to be doing Geometry Chapter 4, Applying Triangle Sum Properties. The book that I'm using is called Larson Geometry. This is a free PDF online. If you would like to use this book, it's going to be in my comments linked to this video. But also, if you're using another geometry book, you'll be able to follow along just as easy. All right, so let's begin. So the objective of this lesson is to classify triangles and find measures of their angles. And as always, we're going to sit there and start with our vocabulary for this section. So the first one is going to be a triangle. A triangle is just a polygon with 3 sides. All right. And then we're also going to look at interior angles of triangles. And interior angles of our triangles are just the inside angles of our triangle. And then our exterior angles of our triangles are just the outside angles of the triangle. And then again, when we get into proofs and theorems and stuff like that, we have corollaries. And corollaries are just a statement that can be proved easily using a theorem. Okay. And those are the main vocab words that we're going to use in this section. There's going to be more for chapter 4. Okay. So again, our key concepts for this one, since we are looking at triangles, we have like 3 different kind of triangles that we're going to look at. So we have scaling triangles, where it means none of my sides are congruent. Isosceles triangles, which means that at least 2 of my sides are congruent. And then equilateral triangles, which means that all 3 of my sides are congruent. And then we have acute triangles when we look at our angles, which means all my angles in the triangle are going to be less than 90 degrees. We have a right triangle, which means that at least one of my angles in my triangle are going to be right. And then we have obtuse triangle, which means that one of my angles are going to be more than 90 degrees. And then we have equilateral triangle, which means all of my angles are going to be congruent or equal. Right. So let's start with focusing on example 1. And for this one, it says classify triangles by sides and by angles. Classify the triangle shape of the support beam in the diagram by its sides and by measuring its angles. For this one, we're not going to sit there and measure their angles because it's not going to be 100% correct if I measure it online like this. But we're going to look at this triangle and say what kind of triangle it is. Since it does have 2 congruent sides, then that means it's going to be an isosceles triangle, just like how we had in our theorem right here, isosceles triangle. All right. So we can just sit there and call it by that. Okay. Triangle. All right. And that one's simple enough. And so for example 2, right here, they want to classify a triangle in a coordinate plane. So classify triangle PQO by its sides, then determine if the triangle is a right triangle. So this is like a 2-step problem. So let's begin. First thing we want to do is find all the sides of our angle by using, or of our triangle by using the distance formula. I already have the distance formula written out right here. So we can go ahead and start using that. Let me just get my pen set up right here. There you go. So first thing we're going to find is OP. So I can always when you guys do a test and you're using the distance formula or slope formula, it's always best practices to sit there and annotate your points by putting X sub 1 and Y sub 1 on your points. No, this is acting tricky right now. It's not letting me write. So I would put x sub 1, y sub 1 right here, and then x sub 2 and y sub 2 right here. I'm not going to do it right now because it's kind of acting funny when I write. So then we just substitute in our points. All right. So my x sub 2 is going to be -1 and then -0. And this is going to be squared. And then plus, okay, my y sub 2, which is 2, and then my y sub 1, which is going to be 0, 2 minus 0, and that's squared again. All right. When we simplify that down, I get the square root. -1 minus 0 is just -1. -1 squared is just 1. 2 minus 0 is just 0. 2 squared is 4. Square root of 1 plus 4 is just going to be square root of 5. And we can just leave it at that. So we know the side P0 is square root of 5, or PO, my apologies. Okay. Now let's find our side. I keep on wanting to say 0. OQ. So OQ again, I can have this as my x sub 1, my y sub 1. This point right here as my x sub 2, my y sub 2. Okay. It doesn't matter which one you pick as your x sub 1 and y sub 1, or x sub 2, or x sub 2 and y sub 2. Just as long as you stay in accordance with so. All right, so for this one, x sub 2 minus x sub 1, so x sub 2, that's going to be 6. My x sub 1 is 0. And then plus my y sub 2 minus y sub 1. My y sub 2 is 3 minus 0. And this is squared. And this is all under that square root. Then I simplified down. 6 minus 0 is just 6. 6 squared is 36. And then plus 3 minus 0 is 3. 3 squared is 9. So 9. Again, this is all under my square root. 36 plus 9 is going to give me 45. So I have square root of 45 right here. I'm not going to simplify down my square roots. I just want to sit there and see if I have any equal sides or how my sides relate. And now this is square root of 45, just marking down my sides. Now let's go ahead and find PQ. Again, I just plug and chug. So my x sub 2 in this case, I'll use these ones as my x sub 1, y sub 1, and this one as my x sub 2, y sub 2. So my x sub 2 in this case is going to be 6 minus -1. I do have to account for that negative. That minus is part of my formula. Okay, so let's write it like that. Now my y is 3 minus 2. And that's squared. Simplifying this down, a negative times a negative. This is going to become positive. So I have 6 plus 1. That's going to be 7. 7 squared is 49. So I have 49. And then plus 3 minus 2 is 1. 1 squared is just 1. So this is going to equal square root of 50. Now I notice that none of my sides match. Okay. All of them are different. So this means that this triangle is going to be scalene. Okay. And we'll note that down at the end. Okay. Or I'll put it right here. Let's put scalene. Just to note it down. All right. Scalene means that none of my sides are equal. They're all different lengths. Now we have to sit there and see if this is a right, if this triangle has a right angle. Now remember, right angles are perpendicular, all right? So we can use the slope to sit there and see if they have a right angle. Because if I have opposite reciprocal slopes of two of my lines, that means they're perpendicular, and perpendicular means that I have a right angle, okay? So let's test out PO first. So let's find the slope of PO. Right, in my past video, I have the formula for a slope. Slope is just your difference in y's over your difference in x's. So that would be m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 2 minus x sub 1. Okay, that's our slope formula. And like I said, best practices is to annotate and put which one you're going to have as x sub 2 and y sub 2. So for now, I'm going to have this one as my x sub 1, and this one as my y sub 1, this one as my x sub 2, and this one as my y sub 2. So let's go ahead and find the slope for this. So my y's, I'm going to have, let's do 2 minus 0 over negative 1 minus 0. Okay. That's going to equal 2 over negative 1. Or I can just write this as negative 2. Okay. So now let's find the slope for OQ. Okay. So for this one, I'll pick this one as my x sub 1, y sub 1, x sub 2, y sub 2. So 3 minus 0 over 6 minus 0. That's going to give me 3 over 6. 3 over 6 reduces down to 1 over 2. Now, if I can sit there and see, the opposite reciprocal of negative 2 is positive 1 over 2. So both these slopes are opposite reciprocals, which means that those two lines are perpendicular, and perpendicular lines form a right angle. Okay, so I just proved that there is a right angle in this triangle. Right, so the type of triangle this would be called is a right scalene triangle. I'll just put right. Scalene. And I'll just draw a triangle. Okay, and that's what type of triangle this is. So you could, there's other ways you can sit there and check for a right angle. I just think it's easier using slope. But if you want to sit there and see another way you can prove it, go ahead and put down in the comments and I can show you a different way. Let's move on. So let's go over some of the theorems that we'll see in 4.1 and then throughout chapter 4 as well. So this first theorem is the triangle sum theorem. This theorem is just basically saying that all my angles, my interior angles of a triangle, will always sum to 180 degrees. I also have the exterior angle theorem. This is saying that the measure of an exterior angle of my triangle is equal to the sum of the measures of the two non-adjacent interior angles. I like to think of it as that my outside angle of my triangle will always be equal to the sum of the two angles that are far away from it or not touching it. Okay. And then we have our corollary to the triangle sum theorem. This one is basically saying the acute angles of a right triangle are complementary. Remember, when two angles are complementary, that means when I add them together, they'll equal to 90 degrees. Okay. So that means angle A plus angle B will equal to 90 degrees. Now, in this book, they do prove the triangle sum theorem. Sometimes teachers will put this on a quiz or a test because it is an important theorem and it's very basic to prove. I don't have time to prove it in this video, but if you do want to see this proved, put down in the comments and I will show you step by step how to prove this theorem. So let's move on to example 3. This one says find the angle measure. So find the angle measure of JKM. So we're looking for JKM. We're looking for this outside measure. Now remember from our theorem, our outside triangle, or exterior angle triangle theorem, that if I add these two angles together, it's going to be equal to this one. So I can sit there and set this up as X plus 70 is equal to 2X minus 5. Now I'm just going to sit there and use algebra to sit there and solve this through, okay? So let's get all my constants on one side and my X. Let's isolate it. I'm subtracting 70 from both sides. So when I subtract 70 from both sides, I'll get 2X minus 75. Then I'm going to subtract that 2X from both sides. When I subtract that 2X from both sides, of negative X equals negative 75. I divide both sides by -1. So then my X can be totally isolated. I get X equals 75. But we're not done yet. They didn't ask me to just find X. They asked me to find the whole angle, JKM, this one right here. So now we're just going to have to use substitution. Everywhere I see an X, I'm going to sit there and put 75 minus 5. Okay. And I just keep on solving down. So 2 times 75, that's going to give me 150. 150 minus 5, that's going to give me 145. All right. So to answer this one, that exterior angle of that triangle is going to equal 145 degrees. Okay. Let's keep going. I believe this one will be our last one. For this one, they want us to find the angle measure from a verbal description. The tiled staircase shown forms a right triangle. The measure of one acute angle in the triangle is twice the measure of the other. Find the measure of each acute angle. All right. So these are acute angles that they're given, and then we sit there and we have our right triangle. Remember from our corollary, they say that both of these acute angles of a right triangle are going to equal to 90 degrees. So let's set that up as an equation. I have 2X plus X is equal to 90 degrees. And then I just add my like terms together. I have 3X equals 90. I go ahead and divide both sides by 3. I'm going to get X equals 30. But I'm not done because they want us to find the acute angles. So I use substitution. 2 times 30, that's going to give me 60. And then this X is just 30. And later on, we'll get more used to these triangles. These are called 30, 60, 90 triangles. Okay, and we're going to deal with those later on. All right, so we're going to stop right there at 4.1. Again, if you have more homework questions on 4.1, want to sit there and work through some proofs, or have questions on the homework problems in this book that I'm using or your book, just put it down in the comments or send me a comment and I can show you and help you out. If you have any other homework problems or questions dealing with math, subscribe and leave me a message. Thanks, guys.